So for those of you who do not know what tokenization is, tokenization basically acts as a code check for your sensitive data. So you give ALTR your plain text sensitive data, and we store it very securely, and we give you back a token that looks exactly like this, just a string of alphanumerics. Whenever you want that sensitive data back, an authorized user can send back ALTR this token, and we'll give you that plain text value back. Just a segue in this demo here, I've got this customers table with some SSNs, some names here that have been tokenized, as well as age, weight, and gender. I've also got this transactions table you can see on the left here, some SSNs, some dates of the transactions, the amount of the transaction, and the state that the transaction was placed in. And you can see here that in ALTR I've set some policy that says for this data scientist role, for this tokenized name column, I'm going to allow detokenize and show the value with plain text. For SSN, I'm gonna allow it to detokenize and show the last 4 digits with a masking policy, and the same thing for the transaction table SSN. So if I go ahead and run that, you can see here give it a second here for my warehouse to spin up, but you'll see those SSNs and those names will be detokenized, and then we'll apply a masking policy on the SSN column. There we go. One really cool thing about these tokens that I'd like to mention is they are deterministic, which means that they retain referential integrity. Now, the really nice thing about that is, let's say I wanted to do a join on this tokenized data without actually detokenizing it. I could do that because let's say if I tokenize the word apple, I'll get a token back. If I tokenize that word again later, I'll get that same token back. So that means, let's say I wanted to tokenize the same SSN twice, I'm going to get the same token back. So I can still do joins on those tokenized SSNs because they're the same tokens in each table here. So this is exactly what I'm doing here. So I'm going to run a query to find out, using a join on this transactions table with a join on this customers table, joining on that SSN field, how much mails and texts have spent in total. And we'll go ahead and run that. So we can see here that mails and texts have spent like 72,000 here. And that join is on that tokenized data. One more thing I'd like to mention here is how we get these tokens into Snowflake. So there are many different ways to do this, because all it takes to get these tokens is an API call out to ALTR. So this could be done at so many different points. For this example, I have an S3 bucket set up that whenever you drop a JSON file in it, it'll run a Lambda to tokenize, make a call out to our API and tokenize that data. And then with the Snowpipe, we can get that resulting data into Snowflake without automatically. But there are a million different ways to do this wherever you want to do it in your ETL process. We have a very nice integration with Tillion that'll do this tokenization for you. You can also do it in place inside of Snowflake. So if you wanted to run an external function call that made a call out to that API, that is another way to do it. It's really all a function of your data pipeline and your tolerance for your data being exposed. So if it's a very low tolerance for your data being exposed, you may want to do that tokenization before moving it anywhere. Thank you for watching this Vault tokenization demo.